Right, we are to continue from where we left last time. That is control structures, and we are continuing with the control structures. Still remember, we ended up discussing about the decision maker, and on the decision making, we only touched the if statement only, talked about the if statement, and we need to proceed to the other construct which falls under decision making. That is the select case. Right, so the select case, it takes a different way altogether from the if statement, but it is used also to perform decision making, selection, and branching. So it is mostly suitable when we have a, a variety of options, or when we have a list of options which our program can take. Unlike if we have two options, it's not relevant for us to use the select case. But we can use it, but it won't be relevant. It won't be wise for you to use the select case when the program has got two options. So we want to convert this program which we are looking at, so that we can use the select case. Both one has got several options. But before we have the actual program, we need to write the syntax. To give you the syntax of the select case. What will be the syntax of the select case? We are talking about the select case. So it starts by the word select. That is the word select case. Then we have the variable. Then we have case. Option 1. We have statements. So this one was case 2. We proceed to case 3. We have statements, and sometimes we will have what we call case errors. Then we also have this statement, and lastly we have the end statement. Right. So that will be the syntax of the select case statement. So it's select case, then we have the variable. So this variable is the one which will assume the values on the option 1, option 2, option 3, option, and case else. So what I was saying here, we are saying that the variable, the type of the variable, we'll talk about data types. The type of the variable must be the same with the values which are going to be entered on the option 1. Must be the same with the value which is going to be entered on option 2. Must be the same with the value which is going to be entered on option 3. And the statements here, we are referring to legal statements in VB. I understand we talked about this on the previous lesson, issue of legal statements, so we cannot continue emphasizing it. And I understand everyone knows what is meant by that statement, legal statement. If you are not, if you haven't visited that previous lesson, I think it's necessary for you to visit it, for you to understand some of the concepts, because they will be developed from that previous lesson. Right, so that's the syntax of the select case statement. So now we want to use write a program. We want to answer the question, write a program that will affect the mark from the user and determine the grade using the criteria below. That is 80 to 100 grade distributions, distinction, merit, and until we reach the invalid mark. Right, so using the select case, the accepting, it will be the same. So just select case, select case, the mark. So you're selecting case variable. Our variable is what? Is mark. Then we now give the case now. So in this case 80 to 100. So case 80 to 100 can display what? This is distinction. So programming is all about copying and pasting. I will display distinction. Distinction. Case 70. This is 60 to case 70. Now merit. Case 50. 59. If pass. And 0 for the sphere. And the last one, that is the case else. If all the other options are not correct, then this one will be taken. Right. So this is the program, and to me it looks very clear. It's more clearer than the if statement. That is the last form of the if, because we achieved this using the last form of if. So this one to me is more clearer and is more easy to understand to me, but to you sometimes it might be very difficult to understand. It might be complex, might not be simple as the way I'm seeing it. But to me, it sounds very simple, sounds very straightforward. So we want to run to see whether it is yielding the same results like what that one, the one which we wrote yesterday. It's yesterday, it's yesterday on previous lesson. Right, it's like I changed this. Right, enter mark and press enter. So it's 67. It's made it. Let me run again. Change the command prompt, the colors of the command prompt to this one. And let's enter 89 distinction. in, enter, let's say in abnormal, invalid type. So it shows that the program is running the same. The program is doing the same selection, but what differs is the construct which has been used, which is the select case. Like what I said, that this one to me is more clearer as compared to the if statement, and it's more simple. It's more simpler than the if statement to me. But to you, it might be the if statement may be simple as compared to this one. So in an exam, let's say probably you are writing an exam. The question might just requires you to write a program that will perform decision making. It's upon the way you're able to use these two constructs. You choose the one which you want to use. You are not to opt for the select case. You are not to opt for the if statement. But if you are good at using the if statement, then you can use the if statement. And if you are good at using the select case, you might also use the what? The select case. But otherwise, I personally recommend the select case if you have more than two options to be taken by your program. That's when I recommend using the select case. Otherwise, we can say goodbye to decision making. Let's proceed to the next construct. That is the next construct that will be looping, iteration, or repetition. That is the last construct which we had to talk about. Right. Looping, iteration, or repetition is a control structure. That is the last control structure which we use in programming. Sometimes we might want to perform some repetition. Sometimes we might have some operation which we want to repeat. Probably we are performing some repetitions, or sometimes we want to repeat a certain operation. Let's say we want to repeat entering a number, or we want to enter the same number several times, or we want to enter several numbers or different numbers but several times. We cannot prompt the user. We cannot write our code like right line in the number, right line in the number, right line in the number, right line. Probably you want to enter 10 numbers. It's not logically good. It's not a logical way of prompting the user manually 10 times. But you need to use the repetition control structures to perform and to repeat a certain operation. We need to use the repetition control structures. So we have three constructs which falls under the repetition, iteration, and looping control structure. Three constructs. These are the for loop. We also have the do loop, and last we have the while and the while. So these are the loops which we have. These are the constructs which we have, which falls under the looping, repetition, or iteration control structures. So we are going to discuss one construct after another for us to grasp um, those constructs and how to use them and when to use them. That's what is necessary. That's what is very, very important. So begin with the for loop. Like just following the logic has been put there. Right, the for loop, it is used to perform repetition when when the programmer knows in advance the number of times to be repeated. If you know the number of times to be repeated, that's when you can use the for loop. What am I saying? We are saying that if the number of times to be repeated is predictable, even sometimes you might not know the exact number of times. The exact number of times cannot be known, but if it can be predictable, if it is predictable that this it can iterate for this number of times, or if the number of times can be calculated, because prediction sometimes we are not going to the specific, because we want a specific number of times. So if the number of times can be calculated, even if it's not static, even if the number of times is dynamic, but as long as it can be calculated, that's when we can use the for loop. So if the number of times is not specific and cannot be calculated, then the for loop cannot be used. Note that the for loop cannot be used if the number of times to be repeated is not specific. At the same time, if the number of times to be repeated cannot be calculated, then you cannot use the for loop. We need to go or to opt for other loops. But if the number of times can be calculated, or if the number of times is specific, that's when you can use the what? The for loop. What is the syntax of the for loop? It's for. For is the reserved word for variable equals to start value to end value step value. We have statements next. Right. So this is the syntax of the for loop. For variable equals to start value to end value, step value, statements, next variable. Right, we need to explain a little bit on the components which makes up the for loop. Right, for is a reserved word, to is a reserved word, step is a reserved word, next is a reserved word. So we have for, to, step, next. That's why sometimes people might call it the for, to, step, next loop, trying to come up with the components which makes up that for loop. So that's what other people might end up saying or giving that name. Right. So the variable now, this variable must be of type integer. We'll talk about types on another lesson. But what is this type? This type of an integer, we are referring to types that holds whole numbers only. So the type of this variable must be of whole number. And the start value must be either a literal integral value or a variable of the integral data type. It must be a literal integral value or a variable of the integral data type. it is the same with the end value. It must be either a literal integral value or a variable of the integral data type. The same with the step value. Again, it has to be an integral, a literal, or it might be a variable of the type integer. So we are saying that start value, end value, and the step and the value after the step must be of the type integral, or they might be literals. It's allowed to use literals. By literals, we mean the exact values. Like in this case, we are talking of the numbers 1, 2, 3, 4, 5. Those are literals. They are exact values. You cannot change because 2 remains 2. That's its value. You cannot change that value. That's why you cannot say 2 equals 2 something. You cannot put 2 on the left hand side of the assignment operator. We'll talk about that when we will be discussing about the error values and error values. We'll talk about that anyway. So those are the components which makes up the follow. Then the statements. Okay, we left out the statements. Statements are the same with the statements which we discussed on previous lessons, and that these refers to legal statements in VB. And the next variable is the same variable of that type. So that's the syntax of the for loop. So for us to understand it, I know people want to have the actual program, see it running, then they will believe that surely we are we are now performing repetition. Right. The question, simple question, right? A program that will display the word Soki 5 times. 5 times on the screen. So that's the question which we want to write. It's a very simple question. Write a program that will display the word Soki 5 times on the screen. Right. So we want to use that. Obviously, we need to declare a variable. Or we can say I. Yes, most people use I for index. Then for I equals to, we want 5 times. So 1 to 5. As we say 1, 2, 3, 4, 5. So we start from 1. Then we display a right line. So key next. Right. So that one line will, if we run our program, we'll see that Sokiri will be displayed 5 times on the screen. Displayed 5 times on the screen. Right, we can even try to count it. How many times it has been displayed? Right, 1, 2, 3, 4, 5. Right, so it has been displayed 5 times. But we used how many statements here? Only 1 time because of the construct. So that's how we use the for loop to perform repetition. So we can, but this is very, very simple. It doesn't mean that when you are using these repetition control structures, that's what you will be doing. Very simple like this. Sometimes you see that you need to infuse the decision making inside the repetition. Sometimes you might want to infuse the repetition inside that repetition again. We call that nested. nested loops. Sometimes you might want to perform a for us to achieve, I mean, a certain operation, we might be required to nest the loops. We might be required to infuse uh, decision making inside the what? Inside the repetition. For instance, a question might say write a program that will display all even numbers between, or not between, but from 1 to 20. All the even numbers. That's the question. You know the definition of an even number from our previous lesson. You know how to write a program to determine whether a number is an even number. But here the question is asking or is requesting you to write a program that will display all even numbers from 1 up to 20. The even numbers which are found between 1 and 20. So it means there is issue of repetition. At the same time, there is issue of decision making. So how do we write that program? They say we are only changing 1 to 20. That's the range which we have been given. Then here we make decision, right? That is if I mod 2 equals to 0, then I write line. Or you can say write if you want, but let's say write line. Write line I. Yeah, then. Want to see whether the even numbers have been displayed. Right. Those are the even numbers 2, 4, 6, 8, 10, 12, 14, 16, 12. Those are the even numbers displayed by that code. So you need to be in a position to think. That's programming now. It's different from coding. Because coding is like just turning the instructions from one language to another. That's coding. But programming now is about thinking. That I have these building blocks. So how do I solve this problem? Which building blocks should I infuse? Which building blocks should I use? Why should I use this one instead of this one? That's programming now. So that's what you are supposed to learn, and that's what you're supposed to do. And to not to avoid, I mean to say, to avoid more confusion, which I can put in you. Let me end here. I know because where we are going now is like the higher you go, the hotter it becomes. So we want to keep it simple. So let us end here. Our next lesson we will proceed into the next loop, that is the do loop until. Then I understand we might even finish the those two loops, do loop until, while and while. That will be our next lesson. And remember, programming is like martial arts. You learn it through doing, not through reading of books. Whatever we are doing, whatever programs I'm writing here, you're supposed also to write them and practice, run them, and try again to make some changes. So that if you change it to this, what will happen? If you change it to this, what will happen? You start you have your own observation, and you that's how you learn. And don't just practice the codes which you are seeing on the screen and end there. No, you are supposed even to change, even to add some, to remove some, and to see what will happen if I remove this, what will happen if I add this, what will happen. That's what programmers do. And through that, you will learn, you will grow, will become a developer.